We will now look into the second major classification of data types: the user-defined data type. Remember that we learned about three major classifications of data types: primitive, user-defined, and derived. The user-defined data type is a customized data type that can be set by the programmer, and is usually defined using the built-in primitive data types. Let's have a look at them. Typedef. The Typedef user-defined data type is used to rename an existing data type. It provides a level of abstraction by allowing to create an alias or additional name. For example, typedef int money. It defines that data type int is also called money and can store an integer value. Continuing with this definition, we declare money, debit, credit. This is a declaration that debit and credit are memory locations that can store integer values for the user-defined data type termed money. Note that money with capital M is different from money with small m, because C++ is case sensitive. We next declare debit equals 5,500. Here we assign the value 5,500 to a variable or memory space named debit. Next we declare credit equals 123,950. This assigns value 123950 to the variable credit. Cout, debit. It prints the debit value onto the display screen. Cout credit. You now print the credit value onto display screen. So, what did we do here? Using the typedef keyword, we first renamed, or defined, the built-in C++ data type int, with a new name, money. We then declared integer variables debit and credit to the customized data type named money. We assigned values to them. And then we displayed them. Let's move over to the next user-defined data type structure. Data type struct is used to create a group of different data types as a single entity. For example, suppose we have an assignment with some sports management project, and we want to handle some sports-related data, then we may declare a data structure with the keyword struct. The structure is named sports. I declare an integer variable named seating_capacity. Next is declared a float variable termed ticket_price. Note that each declaration ends in a semicolon, and the structure too ends in a semicolon. So here, we declared a struct data type named sports with a couple of member variables. Number 1. Integer variable named seating_capacity. And number 2, floating point variable named ticket_price. We can thus create multiple units of memory blocks for different sports like football and boxing by writing the following statement in a C++ program. Sports, football, boxing. This declaration, also called initialization, creates memory blocks that will store the seating capacity and ticket price for each of the specific sport. Is it clear? Okay, I will demonstrate to make it look much simpler. This is how we had declared the structured data type named sports. It had two member variables: seating capacity and ticket price. We then initialized the structure termed sports with two struct variables named football and boxing. Initialization is the actual creation of memory block space. So when the structure sports is initialized with football and boxing, memory blocks are created, where the football memory block stores values specific to football. Here the seating capacity for the football stadium is assigned as 50,000, and the unit ticket price is $150. Similarly, the memory block created by structure sports for boxing could have a seating capacity of 10,000, with a unit ticket price of $300. Next is union. User-defined data type union is similar to the struct data type. It is used to create a group of different data types as a single entity, but allows the storage of only one value at a time. Union allocates just one memory space, with a fixed address for all the values declared in it. The allocated memory has a size, which is the size of largest data type declared within it. Also, union remembers only the value that is most recently added to it, as newer values overwrite the older ones. For example, suppose that an office provides its employees with incentives of cash, grade promotion, or gift. Normally, an incentive can be any one of the option at a specific time. Nobody gets all three incentives on a single occasion. So here, I declare a union data type that is capable of retaining any one value from several possible other values. I name it incentive. We then declare a group of variables. Float. Cash, to store cash amount. Char grade, to save a single character office grade. And char gift, to store max 50 character gift name. Assuming that for the Christmas season we provide a gift as the incentive, we assign plum cake to the variable declared as gift. Similarly, at the financial year ending, we provide cash as incentive, and so we assign a numeric amount to cash. Note that memory occupied by the union, named incentive, is 50 bytes. It is the size of largest data type declared in this union. For financial year ending, the incentive occupies memory size of 4 bytes because amount in cash is a decimal number. And hence, a float value. So union can hold values for different primitive data types, but can only hold value for any one of them at a time. We will learn more about unions later. The next user-defined data type is enumeration. Data type Enum is a user-defined data type that can enumerate or assign numeric values to a set of constants defined within it. Enum activates only one value from many available possibilities. Enum comes handy at occasions where we work with a set of related constants, but need only one among the options. For example, we declare here an enum. Let's name it score, which stores a group of values. Absent, fail, pass, distinction, and %. Note that each declaration ends in a comma. The last one need not have it. The variable absent is auto-assigned the value 0. Fail gets the auto-increment value 1. Pass is assigned a value 50, distinction is assigned 75, and %_ is assigned value 100. During program execution, enum can be assigned with any one value from the set of given values. We will learn more about enumerators in later sections. Class. The user-defined data type class is used to create a group of different data types as a single entity, similar to the struct data type. However, the class also contains functions or operations that process the data. For example, the class data type named employee is declared to handle 5 data variables. Name as char, for max 20 characters. Age as int, to handle integer values. Basic pay, DA, and HRA as float, to handle decimal numbers. There are 2 functions. Calculate total salary function and print salary details function. Note that each declaration here ends in a semicolon. The class is a form of logical memory space that stores a package of encapsulated data, and functions that process those data. More on class in later chapter.